Welcome back to Algebra 2, Chapter 6, Section 9. In this book, we've been doing some pretty fancy math, I'm telling you. Alright, so this chapter is called Modeling with Polynomial Functions. I think of it as carrots and cubic regressions. But those fancy math words don't stick in my brain that good. I like the concepts stick in my brain. And so hopefully it's starting to stick in your brain too. Okay, so what you're trying to decide is, it says, if y values for equally spaced x values can be modeled by a polynomial function, you can use finite differences. So what we're looking for is a pattern, because we have evenly spaced, and this is how you do it. Okay, so here is my equation, and I changed it to x's from n's because we're more familiar with that. So my equation, y or f of x equals 1/2 times x squared plus x. And what I'm going to do is I'm going to do my if-then chart, but I'm going to write it a different way, but I'm going to remind you how to do an if-then chart. We're going to start with 1, always with 1 when we do this. So if x is 1, 1 squared is 1, plus 1 is 2, times 2, the 2's cancel out and you get 1. Does that make sense? If x is 2, 2 squared is 4, plus 2 is 6, 6 divided by 2 is 3. 3 squared is 9, plus 3 is 9, 10, 11, 12, times 1 is 12, divided by 2 is 6. So that's how we normally do our if-then charts, but we're going to make it look different. We're going to do our x's like this, f of 1, 2, 3, 4, 5, 6, 7. So what's in those parentheses are the x's we're going to try. And then we're going to put it in and we're going to write the answer, the y, underneath. So these are the ones I did, 1, 3, 6, 1, 3, 6. And if you fill in 4, you get 10. And you can even do this on your calculator. You can put 1/2, parentheses 4 squared plus 4 and get your 10. You don't have to do it in your head the way I was. I'd like you to be able to do it in your head, but you don't have to. So 5 gives 15, 6, 21, 7, 28. Okay, so there's our numbers. Now what we do is we draw what I had a student I used to teacher call. She said these are carrots. So draw your carrots. Each of those are carrots. Okay, you can draw them orange if you want. And then what you do is you take this second one and you say minus the first one and write it down. So 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 is 5. 21 minus 15 is 6. 28 minus 21 is 7. Ooh, look, we're starting to get a pattern. That's what we're looking for, patterns. Okay, now we do it again. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. 6 minus 5 is 1. 7 minus 6 is 1. And so they all turned into 1. That's what we're looking for. It doesn't have to be 1, but they all need to turn into the same number, and when they do, we're done. And because we got them all the same number, the answer is yes. Yes, this can be modeled by a polynomial function. And okay, so this was our first column on our if-then chart. When we got our answers for the first time subtracting it, those are called our first order differences. Not the y's, those aren't differences, those are our y's. These are our differences because we had to subtract for them. We had to subtract again for these. So these are our second order differences, and I'm trying to figure out what this has to do with Kylo Ren in the first order, but I don't know if it does. Okay, probably not. So that's what you name these things. Because we have second order differences, we know that this is going to have x squared and it's a quadratic function. If we had done it 3 times, it would be a cubic function, meaning that our x's would be x cubed. So if you go and look at example 1 in your book, then it has got 3 things being multiplied. So it is a cubic function. And for example 4, where they did this, they were able to do it 3 times before they got them all the same. It is also cubic. Now, if you have points like they did for example 1, you can use your calculator, put them in under stat the way I showed you to with a linear regression, then go to calculate, and find where it says cubic reg, or whatever it has for cubic regression, cube reg, probably cube reg, and then you can do a cubic regression and get the equation, and that's what I want you to be able to do. So example 1 has 3 x's, so it was cubic. We can put those 4 points they give us in, do the cubic regression on our calculator, and we can get the equation. That is what I want you to be able to do. This is kind of fun and interesting, and it certainly looks fancy with the carrots. This is what's most imperative, that you can take points and or data and turn it into an equation. Example 4, they've got, and they show you more how to do it on your calculator and how to put in that data and get that equation. All right, so this is it for chapter 6. Do your test. If you're doing it as a class, do your test, and then come back and we will do chapter 7, which will be just terrific, and we'll learn all kinds of wonderful things. I'm flipping to see what it is, as you can tell, but there's a billion pages between 6 and 7 in the teacher's edition. Oh, powers, roots, and radicals. Those are fun. And we have great pictures of dinosaurs here. I like dinosaurs. All right, math is great.